So I think you are live. Hi, everybody. My name is Roberto Alvarez. I'm the Executive Director of the GFCC, the Global Federation of Competitiveness Councils. If you are not part of the GFCC community and this is your first time here, the GFCC, it's a global leadership network. It's a membership organization. We have four types of members: universities, corporations, government agencies, and private sector entities. We combine those four segments at a global scale. We're here today for one of our open online events. And by open, I mean we have members and fellows of the GFCC here with us in attendance, but also this is open to a general outside audience. So thanks for joining us. We have an amazing session here today. This is part of our series on resilient infrastructures for the future, with a focus today on physical infrastructures, and especially how we can build resilient physical infrastructures in the age of extreme weather events. We have two amazing speakers here today. We have Ben Paul Gilmore from Lockheed Martin Corporation and Sebastian Thauch from the Western Sydney University. This session was organized and is being presented in partnership with Lockheed Martin Corporation. So, Hector, I know you are somewhere, so thanks for all of your work, and all colleagues of Lockheed Martin, Christopher Geiger, and all colleagues for making this possible. Western Sydney also is a member of the GFCC, so we have representatives from two GFCC members here today, Lockheed Martin and Western Sydney. We want you to be part of the conversation. This will be fast, dynamic, but we want you to engage and ask questions. We will start with presentations, then we have some conversation with the two presenters, and we will open for questions from the audience. If you have a question, please enter that question in the Q&A feature here on Zoom. And for us to get started, I wanted to invite GFCC President Deborah Winston-Smith. Deborah, you've been working at the nexus and the connections between infrastructure and competitiveness for quite some time. So over to you, and thanks for being here, Deborah.
Thank you, Roberto. And let me also thank all of you who are joining us today for this webinar. And I want to, first of all, thank Lockheed Martin, Christopher Geiger and his team for their support and sponsorship of this very important session with leaders of the GFCC. And of course, our two distinguished speakers, Ben Paul Gilmore from Lockheed Martin and Sebastian Thauch from Western Sydney University. Well, infrastructure writ large is one of the critical building blocks of a competitiveness strategy. Infrastructure encompassing everything from the infrastructures of intellectual capabilities, intellectual property, policies from antitrust, competition policy to cyber infrastructures. It really covers the gamut, but it's really how these infrastructures are integrated into other critical components of policy that create a dynamic competitiveness strategy. Everything from tax and fiscal policies to investments in research and development to everything, including what's going on in the digital infrastructure, cybersecurity, now AI, to create the capabilities for productivity growth and increasing our economic strength and national security. And today, of course, we're going to talk about resiliency in the context of the physical infrastructure, but very much dealing, as Roberto said, on extreme weather. We have been really focusing on the infrastructure building blocks in the GFCC for many years. This is one of the building blocks that we feature every year in our competitiveness principles we release at our Global Innovation Summit. We actually, in 2015, in Saudi Arabia, had an entire session for the Global Innovation Summit on infrastructure as well. So I want to welcome you all again. We have these great speakers, but very importantly, we want to hear from you and have an important dialogue as well. So with that, let me also say that on behalf of the U.S. Council on Competitiveness, infrastructures, the enabling infrastructures for innovation capacity are at the heart of our work as well as the work of our members around the world. So with that, let me turn it back to you, Roberto, and we'll hear from our two distinguished speakers and then have a discussion.
Thank you so much, Deborah. We will now turn to Ben Paul Gilmore. Ben Paul has an amazing career. I am an engineer by training, and as I said to you, Ben Paul, I was reading your bio, and it's amazing what you've done. So Ben Paul comes with a Bachelor of Science in Electrical Engineering Technology. He has been with Lockheed Martin after Lockheed Martin actually took over General Dynamics. Ben Paul is a principal engineer and fellow with Lockheed Martin now. He's a certified demand side manager, a certified energy auditor. He comes with a lot of expertise in terms of applying digital technologies to increase the productivity of natural resources and energy from the shop floor to beyond. He has received many awards from the DoD, from Lockheed Martin itself, from aeronautics, some various corporate awards, and more. I think one of the key things and very interesting things that in the plant where he manages, he integrates various systems to deliver efficiency in the use of natural resources, a great achievement, a reduction in 82% of water utilization, among other things. There are many things here that I will not be reading or mentioning, but Ben Paul, it's a pleasure and an honor to have you here today with us. The floor is yours.
Well, thank you. I'm based here in Fort Worth, Texas, at what's called Air Force Plant 4. It's a GOCO facility, which is government owned and contractor operated. The U.S. Air Force actually owns the plant, and Lockheed has operated it since about 1993. This site consists of 131 buildings, 8.5 million square feet, 17,000 employees. I am kind of the chief engineer over all the infrastructure systems, and I'm also over the energy management control system that integrates all these systems together. One of the unique features about this site is all of our infrastructure communicates to one another and works together over one system. And that includes 3 100,000-pound-an-hour boilers, over 28,000 tons of centrifugal refrigeration, 6 700 horsepower air compressors, 6 data centers, over 700 air handlers, over 1,100 variable frequency or variable speed drives that controls fans and pumps. We have 1 million gallon TES storage tanks, and the energy management control system itself has 379,000 IO points to integrate all this together. And our primary feedback for all this data is about $12 million worth of submetering for every single energy input that can go into one of these 131 buildings. So we're able to track everything in real time with the resolution of half a second in order to determine what our electrical loads are. We have 120 megawatts of power that can come into this site through our various substations. And this is all controlled and operated through our energy management system. Now, the thing I was going to talk to you about today is what happened during what we call Storm Uri. It was a major winter storm that impacted the United States back between February 13th and 19th of 2021. It was a severe storm, especially in Texas, where we try to keep things warm. We're not used to 0-degree days, and we had several of those. During that storm, there were over 700 deaths. 3.5 million people in the state of Texas were without power. There was over $26 billion in damage due to that storm. 69% of Texans lost power at some point during September 14th to September 20th. So it was a major significant storm. And sometimes you feel like you're covered because you have contracts in place in case there is an emergency. But like a lot of our contracts for fuel oil that we would use for our boilers in case of a natural gas curtailment, we received one shipment of fuel oil And then because of a major crash on Interstate 35 involving over 130 vehicles and 18-wheelers where 36 people were injured and 6 people were killed, the highways were shut down. Nobody would drive, nobody would deliver fuel. So we were instantly faced with major curtailments on both electricity and natural gas. So we were, basically the gas company wanted to turn our gas off, and we convinced them that was not a really good idea for a DoD site. And so they limited us to a small amount of gas every day. And we were forced to use the energy management control system and basically to determine what we could and could not run. Our normal staffing was greatly inhibited because nobody could get to work. We would normally have a staff of 4 engineers, a couple of maintenance supervisors, 5 operators, 12 mechanics, 12 electricians, and 12 automation system contractors on site. During the storm, we had 1, maybe 2 engineers, 1 supervisor, and 2 operators, and that was it. So the 4 of us had to run 8.5 million square feet, and that would be impossible without the extensive computer system that we have on this site tied into all the infrastructure, allowing us to control everything pretty much from my office. We've actually had to shut down production. I know that may not sound like a big deal, but being that we've never shut down production since 1942, it was a big deal. So we actually stopped production for 5 total shifts because there were less than 250 people were coming to work. So it didn't seem to make any point to keep the plant open. This way, basically, we wanted to do it just to keep all the doors closed and try to retain any heat that we could retain in the buildings to keep our various sprinkler systems, fire protection systems from freezing. This area of the country is designed around 20 degrees minimum and 105 degrees maximum. Well, our average temperature for 5 days was 11 degrees. So we were significantly below a design day. And once again, because of all our buildings were fully submetered, we were able to cut back to the minimum as far as hot water goes, or steam or natural gas. We shut down everything we could. We were able to keep the majority of our systems from freezing, surprisingly. The only major significant freeze event we had happen was in one of our warehouses, and our fire department actually forgot to drain the wet pipe system in that building, and that building was having its roof replaced. So there was no amount of heat I could put in that building to save that sprinkler system. That was really our only major damage that we had during that crisis. But one of the things that the system allowed us to do that was very unique was we were hit with all kinds of penalties from our utility provider, ERCOT, and to get people to stop using electricity, the price of electricity rose, and where we would normally pay $30 or $40 a megawatt hour, the price of electricity rose to $9,600 per megawatt hour. And that's if you're over your hedge, which is the price we had already negotiated and guaranteed. What we were able to do was control our electrical demand down below that level significantly. So instead of buying electricity at $9,600 a megawatt hour, we sold electricity at $9,600 a megawatt hour for every megawatt hour we were below our hedge. And I know that may sound difficult to understand, but let me put it to you in dollars. During the 6-day period, I actually sold electricity back to the grid for $4.5 million. That's how much money I made. I thought I was doing awesome, but they also enacted another penalty that I was completely unaware of and had never heard of, called force majeure. And sounds like something you get at a French restaurant. That had a penalty of $2,000 per megawatt hour, regardless of hedge. So we actually got hit with a penalty of $7.3 million. And then they deducted the 4.5 I saved. So our final penalty was 3.3 million. So at least I greatly reduced the penalty we were going to have. I wish there was something more I could have done about that force majeure, but anyway, that's just the way it goes sometimes. But like I said, we only had one significant freeze event, and we were able to maintain the plant without any issues for the most part, and limited the penalty, and no real coils froze or anything like that. So it was a success, representing what you can do when you have a highly integrated infrastructure control system. It can, basically run by one engineer and two operators for, that entire week. That's all we had. I can't imagine what it would have been like if we didn't have the controls. I mean, it would have taken hundreds of people running around trying to do what we did with an integrated control system. I just wouldn't have been possible. We would have had significant damage in the millions of dollars. That's it.
Amazing, Ben Paul. Amazing. So when we get started, I was mentioning a bit about your track record in natural resources productivity, but what you just told everybody here, it's an amazing case about how different technology layers, from hardware, sensors to software, the whole control system was a fundamental tool to address this extreme weather event. So thanks for sharing that, and we'll have time for a few questions. So now I want to turn to Sebastian Fouch for a different perspective. Sebastian is a professor with Western Sydney University. He works at the Urban Transformation Research Center there. So his focus is very much into cities and urban spaces, especially in light of climate change and how cities and urban settings are adapting to climate change. His research is about urban planning and design, and really about how urban planning and design can be used as a tool to reduce the impacts of rising heat and the rising temperatures. He comes with a background in forest management, plant ecophysiology, and climate change. Sebastian has initiated and managed various Australia First projects related to urban green infrastructures, to the UV smart cool playground, green track for light rail and other systems, AI-based smart irrigation for the Sydney Olympic Park, and others. Again, at the intersection of technology, urban, and climate change. Sebastian is one of the top 2% scientists in the world, and it's a pleasure to have you here, Sebastian. Over to you.
Thank you for that kind introduction, Roberto, and good morning to everyone from Sydney. I know it's any time on this globe where you're joining us from. I've got a few slides that I would like to share with you. I'll just pop them up on the screen. Could I get a thumbs up that you see the full screen?
Yes.
Yes.
Thank you, Elaine. Wonderful. So as custom in Australia, I would like to acknowledge country and specifically the Guringai people and their elders past and present, which are the traditional owners of the land that I am streaming into this webinar from. In the Darug language, the Darug are the greater clan of Western Sydney, where our university campuses are. I would like to welcome you all by saying Warami and Welamabami Jui, which means in their language, hello and good to see you all. Today, and Roberto just mentioned it, I just would like to talk for a few minutes about SIMPACT. And SIMPACT is an acronym which stands for Smart Irrigation Management for Parks and Cool Towns. We have a problem, and that is urban overheating. Urban overheating is the combined result of climate warming, broad-scale global warming, and also urban expansion and urban densification. So any city that you will see on this planet will have what we call an urban heat island effect. Now that we, on top of that, also see climate warming, we have the compounded effect of what we call urban overheating. Here's an example of how this all happens. On the right-hand side, you can see an infrared image of the view in the left, and you can see how vegetation has a much lower surface temperature compared to the built environment, where with a change of surface reflectivity and thermal properties, we very much introduce a lot of warming because of the different thermal characteristics of the built environment compared to the natural environment. And that's exactly what we're doing with cities. Not only when we densify and expand them, but also when we just start to build them, we change how they perform in the landscape. Now, putting it into perspective, and I know you're screaming in from around the world, this is a slide from a survey that was done among the what is called Global Covenant of Mayors for Climate and Energy. This is Europe showing you which mayors of those members, which are around about 11,000 cities, have indicated that extreme heat is already a problem for them today and is increasing in the future. You can see there are cities from Turkey up to Helsinki and over to Lisbon, part of this network of mayors that are very concerned that this, of course, has impacts on their infrastructure, but very specifically also on the vulnerable populations in those cities. So it really is affecting people at very large scale, not only in Australia or in Europe. We have the same kind of studies from the US and Canada and also from South America. So it's a global problem. The IPCC acknowledges that global problem by telling us through a special report that came out in 2021 that cities generally have certain geometries and infrastructure that causes heating up of cities. But very importantly, the greatest cooling effect for cities can be provided by green infrastructure. And we took this on board because Sydney does have a heat problem where we measured already 125 degrees Fahrenheit, which is about 52 degrees Celsius on a summer's day in a place where we have 6 million people living. So we took on a large parkland and said, let's turn this parkland, if green infrastructure is so effective in cooling the city, let's take on a parkland and turn that into a natural air conditioning system. You can see there's urban densification happening in the background with those high-rise apartment buildings. This is a space where over the next 10 years, we expect 30,000 people more living. So what do we do for these people that don't have gardens? Their garden, their backyard is actually the parkland. And we want to provide that as cool as possible and also generate cool breezes that come out of the parkland and then help reduce the temperatures in those urban environments where the people live. How did we do that with Simpact? Well, we used a lot of sensors, more than 300 that were placed into the park. We had 200 soil moisture sensors, and we had lots of other infrastructure that streamed live data into various systems, and I'll explain that in a moment. The park is irrigated. It's built on landfill from a remediation process before way before the Sydney Olympic Park was actually built, Bicentennial Park, bicentenary. So 200 years were celebrated from 1788. So the park was built in 1988 on landfill and therefore has to be irrigated because it has a very thin topsoil layer that doesn't hold a lot of moisture. Therefore, in summer, it gets dry very quickly. So you need to irrigate. We used what we call a combination of forecasting, which is forecasts from the Meteorological Bureau. We have nowcasting, which measures the environmental conditions right now. And then we have hindcasting, where our machine learning came into play, where it learned from the past records how we manage the park and how that can be optimized. And of course, we wanted to include a new experience for park visitors as well and streamed live data onto a web page where people that visited the park could just check where's the coolest place for my picnic, for example. Very quickly, project architecture is like a circular system that we built where you have on the left-hand side sensors in the park. They stream data into the Simpact environment where we have a digital twin and machine learning that creates commands that are sent to the irrigation system. And then you have this loop structure where we irrigate the park. Therefore, we change the conditions. Our tech can pick up how we change the park and therefore optimize the irrigation commands that are sent out into the park. By the way, we heard that at Lockheed Martin, 82% electricity were saved. We saved not as much in water, but we saved about 70% of the traditional application of water by doing it the way that we did for about 1.5 years in the park, irrigating. And we created lots of systems around Simpact where we, for example, streamed, as I said, data, live data for the public, but we also provided a lot of information to the managers of the park, and particularly the surface and irrigation or green managers of the park about moisture in the soil, about sensor status, where different irrigation zones were sitting. We provided through the digital twin maps that were clickable and provided lots of content so that they could start to take control over the system remotely. This is just an example of how we then streamed data live into the park. There were QR codes that people could just scan with their phones, and you can see a park visitor there just next to our weather station. And then there's a QR code that they can scan and check out what the conditions were in the park, and you would get maps, and it would indicate what heat stress you would experience at certain places in the park. So it was really an interactive live streaming service as well for the public. In conclusion, we found by turning this park into a air conditioning system for this particular part of the city that, of course, parks and public green spaces can be used. We've got several papers out that demonstrate this use for cooling by providing up to 3.5 degrees of cooling of air temperatures during the day, but more than 7 degrees Celsius cooling for air temperatures during the night, which is particularly during hot nights very important because people need that respite from heat stress during the day where they recover overnight. And if you have very hot nights, you don't recover. And we actually see after 3 hot nights, the admissions to the ERs here in our hospitals are going up because the people are not recovering from this extreme heat, and the impact on people from extreme heat is just increasing. We were able to maximize what is called the park cool island effect, which is the countermeasure to the very well-known urban heat island effect, by using a very intelligent AI-based irrigation system. And in the end, we can faithfully state that intelligent nature-based solutions, which is called INBS, do have their application in mitigating climate change impacts in our cities. I want to acknowledge that I can't do this work by myself. This is just something that we see more and more for these solutions of very complex problems, either in urban space, in natural space, with natural systems, also, I guess, in any other application where you really address complex issues. We needed help from a lot of other people. We were about a group of 30 that worked for about 2.5 years very intensively on a multi-million-dollar research project to provide this world-first AI-based irrigation systems for public green spaces to cool our cities. I leave it at that and hope you enjoyed this little presentation. I'm happy to take any questions if there are any. Thank you.
Thank you so much, Sebastian, for another great example of how technology can be used in the context of weather events, climate change, etc. Deborah, any comments or reactions to the 2 presentations that we just had?
Yes, I would like, first of all, they were both outstanding. Thank you, Ben Paul, and thank you, Sebastian. Ben Paul, I wanted to ask you a question. Coming out of this experience, which you really managed, I think, to navigate quite successfully in spite of that $1 million penalty you had, the force majeure, which is interesting how that came to play. But what have you done differently? What have you put into your system so that the next time something like this happens, you know, you're going to be able to mitigate faster or to adapt in a way that you won't have a cascading effect, even though you had such a successful outcome?
Well, I guess the first thing I want to do is make sure that our fire department drains any systems where we know we have a potential freeze disaster. That would be one of the things we would do, but that's not really an automated thing, more than just knowing the various construction status around your site. Whenever we have an event, we are always learning from those events, and we come back and we write up what we call facility service requests. They're small funding documents that we go in and mitigate those issues, whether that be like one of the things we discovered during this was some heat tracing that had been installed was on local controllers, and they did not work, and those control systems did freeze and bust and had to be replaced. So we now have a policy of replacing, not only replacing those, but any heat tracing system that goes in has to be controlled and monitored by my system so that we can quickly check and verify their operation. to prevent those kind of problems. So anyway, we do write small projects up, and we go in and make modifications across the site to eliminate these issues. And I can give a success is, coils freezing. That's a very common problem in plants like mine, is that your chill water or hot water coils freeze during these kind of events. I even know sister sites where they expect to lose 10 to 20 coils whenever an event like this happens. We are at a situation now where we have refined that so much, we never lose a coil. We never have one freeze and bust. It just doesn't happen anymore because of all the controls and stuff we've implemented to prevent that.
So my other question before I ask one of Sebastian is, how do you feel secure that you're not, I mean, because your system is so highly integrated, do you feel secure that you could not be subject to a malevolent cyber attack to any one component of this? Because there were a lot of things that happened in this case that were really out of your control that you had to respond to, whether it was the road accident or the fire department and things that, were outside of your perimeter.
Correct. And we mitigate cyber attacks by a very simple practice of, there is no way to access my system from the outside world. There is no remote access.
Good. Okay.
I'm actually not on Lockheed's network. I have my own Air Force owned network that is in no way connected to anything. And that's the way the Air Force wants it.
Right. Sebastian, I'm thinking of your fabulous example of what you've created in Sydney, using natural systems and creating this cooling mechanism. And I'm thinking of a place that I'm involved in through my archaeology and work in Athens, Greece, where the heat situation there each summer is getting worse and worse. And, the urban environment there is very contained. What do you think you have the potential to replicate this in other cities, or is each one going to be kind of customized to the circumstances and structure of those cities?
Excellent question, Deborah. The system itself, Simpact, is built to be modular, so we can scale up or down as much as we want. Everything is web-based, so we can operate this from Sydney if you want to irrigate Athens or Tokyo or Phoenix. That is not a limitation. But of course, as you already indicated, every situation is unique. We don't know what the language is that the irrigation system speaks if you have a smart irrigation system that we can piggyback. So if we have one, then we just need to build like a digital integrator that can then facilitate the language being understood by the irrigation system that we're creating in commands that the Simpact system would send into it. What's the level of digital literacy within the organization where we establish this kind of system? Because that is something that we learned is extremely important, that you not just provide someone with this great solution, but they need to be on board with it and take over and feel ownership of it and see the benefits of it, to then invest time and capacity, resources to really make it work, maintain it, work with it over time. And lastly, what kind of sensory is already on place, on site? Do you have gateways for wireless sensors? Are you operating modems, or is there nothing? Do we have to start from scratch? All these factors will then determine how much your price point varies for each of those Simpact applications. We are in conversations with other countries, particularly those where it's hot and dry. Saudi Arabia, Dubai, United Arab Emirates, they are very interested in this kind of technology. But we're also looking at military sites where you have irrigation systems. We spoke to botanic gardens and golf courses. So the range is extremely broad. And we're looking forward to the next step to really scale the solution to provide widespread cooling throughout cities anywhere in the world.
And I know you need to cool that very hot place in Australia known as Darwin.
And that'll be tricky because half of the year it's wet and hot, and then half of the year is dry and hot. So the wet and hot is something that, particularly with urban cooling solutions, is very difficult anywhere in the tropics. And Singapore can sing a very long song about how difficult it is to keep it nice and comfortable, thermally comfortable, when they have the wet season on.
Thank you.
We have a few questions coming, but before that, I just want to ask both of you, what are your recommendations? Because you are leveraging technology. And I think, as you mentioned, Sebastian, the level of tech digital literacy, it's an important aspect when you think about deploying the type of control and automation solution that you guys have mentioned in two different cases. So if you have to give recommendations for people who are now thinking about designing or planning future facilities in order for those either in industrial settings, and for sure, Ben Paul, you are at the top of the hill. You manage one of the most sophisticated manufacturing facilities in the world. But imagine the rest, right? And you, Sebastian, you are, as you talk, that was one of your first projects, one of the first in Australia, right? But if we think about disseminating this type of technologies and approaches, what are your recommendations?
Can I have a go, Ben Paul?
Go ahead.
Well, the recommendations really come with the identification with a project like that, where you bring new technology into an organization. You have to, from the get-go, you have to define what the benefits will be. And people have to understand these benefits, not just in terms of monetary gain, but also in terms of PR gain, if that is something that you would like to drive, in terms of culture within your organization, that this is able to change and inform and bring to the next step of implementing new technology instead of doing, business as usual, where everyone is busy already and then they say, oh, but this new thing, I don't have time to learn this. This is a barrier you have to overcome. You have to create value that people will actually see and share, and understand that it does not become, another burden for someone that needs to learn something new, but it has to be something that is embedded and will become culture of this organization, where you're trying to bring technology in that will optimize whatever they're doing. In our case, it was the cooling functionality and irrigation systems of green infrastructure, but you can think of anything else, how you manage urban spaces, how you manage factories. It's a culture shift.
I guess my comment on that from where I sit and for what I've seen out in industry is one of the reasons why we are so successful, and I consider us as having a very small staff for having the size of system we have, is that we just have one system, and we do not have a whole bunch of different manufacturers somehow integrated or meshed together, or not meshed together. Frequently, I find sites that they have one system for their electrical, one system for their mechanical, and it's a hodgepodge of systems that have different service contracts with different providers, and it's basically a mess. By us just having one system and that we fully program ourselves, we do not hire a contractor to write one line of code. Everything is in-house developed. And when you're taking care of your house, you're going to do a whole lot better job than you would of a leased house or a rented property. So you have the ownership, and you have the pride and responsibility to make it the absolute best possible. And I think that is the single reason why we have been so successful, is over the last 44 years, that has been our primary goal and objective.
Thank you both, Sebastian and Ben Paul. So mindset shift and integrated command and control in some way, building that by design and having everything integrated by design. So thanks for that. I have a different question about, let's say, risk management, right? Because we are seeing with climate change, we are seeing disruptions in data series, right? So we think about risk. If we want to assess risk using data from the past, maybe that will not lead to the results that many people are thinking about. If we think about floods, heavy rains, etc., right? So what's your take about risk management and how different types of organizations and cities, for instance, could be better prepared to manage extreme events from a risk perspective, risk management perspective?
Happy to jump in.
Go ahead.
I give you a few more minutes to think about
Thank you.
that, Paul,
Thank you.
but Paul, it's no worries. Look, because we work so much with green infrastructure now as a critical piece of infrastructure for cities, it's really shifting from being, the add-on, would be nice to have, to the must-have. So green infrastructure as critical infrastructure also requires different management applications now, because risk from flooding here in Australia, from fire, extreme heat, are very real, and communities and cities and municipalities are experiencing it. So we are now looking at management options for green infrastructure that looks into a combined management effect. So what do we need to do, not only to, let's say, mitigate flood risk of a riparian forest in a city? We also look into, well, when we have this riparian forest, or this, linear park, if you want to call it that, along a river, what do we need to do to also have it managed so it can respond very well to extreme heat? And if there is a fire incident, what do we do to actually manage that as well? So there will be trade-offs. That's very important for us to understand these trade-offs, because if you, for example, want to manage for extreme heat, you want to have lots of irrigated infrastructure that can transpire and provide a lot of foliage that gives you a lot of shade, and therefore, get a lot of cooling from it. But that means your fuel loads go up. And that, of course, can be counterproductive for fire events. So what's the trade-off here, and how do we manage that? So it's very important now to not just have single natural disasters addressed anymore, because we are in this climate era where these disasters, these natural disaster impacts, can follow in sequence very quickly. And we have experienced that in 2019-20 here in Australia, where we had extreme bushfires followed by floods within a week. So it is a reality now that we're facing. And of course, green infrastructure, with all its additional benefits, health benefits, biodiversity, green links, not just the cooling where I'm coming from, but particularly, mental and physical health. We saw this during COVID, where people were loving our parks to death because that was the only way that they could get some respite. It was very important to understand that we manage these parks appropriately. And so there is a shift now that we see in multi-hazard approaches, in different types of managements, how you design, manage, and also help recover those kind of ecosystems in our cities.
And Paul.
So I get my take on it might be a little bit different, but what we have this design concept policy of provide exactly what's required, when it's required, for only as long as it's required. And that's how we minimize utility consumption. And, that kind of gets back into play. You mentioned the water reduction of 82%. And, there was a time we were using 1.2 billion gallons of water a year, where now we use about 200 million. So we've reduced that. The city of Fort Worth never came to us and said, hey, we need you to reduce water. They were excited that we did, but they just assumed that's how much water we needed. Same thing on electricity. We used to have a 55 megawatt demand was the normal. Now we're down to about 27 megawatts. So, we've cut our electricity usage in half. It used to take the energy to build an F-35 used to take over $250,000 worth of energy per aircraft. We've reduced that to $57,000 of energy per aircraft. So we're constantly looking for ways to cut and reduce and control down to the absolute minimum required. Then also have the ability, if there is a crisis like Storm Uri or some other event, we have the knowledge of our infrastructure system and the ability to curtail it down even more for short periods of time. Does that kind of answer your question?
Yeah, I think so. And we got a few questions from the audience here. So let me turn to a few. So Sasha Alexander is asking about the setup, like the collaborative setup, let's say, that cities can have for the optimum use of resources, right? So here's the question. Could there be an ideal collaborative city governance structure and I think that goes to you, Sebastian, for the optimization of resources, the use of big data sharing, infrastructure development in an interdisciplinary context. What would that setup be?
Thanks, Sasha, for that question. It's a tricky one because city governments are normally very closed environments. There's lots of sensitive information that is handled within these organizations. When it comes to research and development and also innovation ecosystems within these organizations, they're not very well developed. It's I wouldn't say cookie cutter approach. If that would be the case, then we have no innovation. There are some pockets of innovation, and it's really important from my perspective and my learning that you collaborate on a level basis. So you're not coming in and telling anyone you need to do this, but you need to come in as a researcher and listen very carefully to understand what is it they need, what is providing them with the greatest benefit, and where's the appetite. And we come back to risk. Because from a research perspective, it's very important to tell everyone up front, well, if we do research, we actually have a great capacity to fail, which gives us the opportunity to learn. And this is how research works. But that, of course, in an organization that has strapped resources, that has very strict levels of, approving project funding for any research, and then always asking what's the benefit for us to do this research. It's very difficult to sell them the aspect of saying, well, we may fail, but this is what we want because we will learn from it and you will get a much greater outcome. So an ideal situation, to come back to the question, an ideal situation is, of course, an environment that is collaborative, that is open, and that is actually able to absorb some kind of failure to really address learning and improvement, because often you need to go through these steps to find the optimal solution for that organization. So that would be my answer to Sasha's question.
Okay. Then Paul, to you, something related to that, but you mentioned having one system and everything being under that roof. That requires coordination, governance, a certain type of organizational setup. What is that? How can companies achieve that? And what's the type of setup that they need to make that work?
It's actually very simple. It's called a single competent authority. That's one person's in charge. Management's responsibility is to fully support and fully fund that person. It's not run by a committee or a team or anything else. It's one person who has the vision, has the dream, and has the expertise to carry it out. And those people are unique and hard to find. And in my situation, you really have to be a master of electrical, mechanical, and software engineering to accomplish all that. And but if you can find that person, that is how you achieve that goal and objective very quickly, because decisions are made in a very short order. Typically, the only thing holds you back is funding. And but once you establish that, in my situation, for every dollar they give me, I give them $3.6 back. So I'm a good investment, and so they give me all the funding they can.
Perfect.
Great productivity metric you just gave us, Ben Paul.
Yep. Sebastian, we have another question for you. We have a colleague asking, and I think it's a colleague probably from Kazakhstan, I would imagine, because I cannot read the name, and please forgive me for that. But Sebastian, did you calculate the ecological footprint of the system that you implemented to compare it with the economic and social impacts it would have?
Short answer is no, we did not, because we had, as Ben Paul alerted, we did not have the funding for that. We would have liked to check a few things within the SIMPACT project. Even though it was a multi-million-dollar enterprise, there were lots of questions we left answered because we were unable to fund them. One of them was, how far does actually the cool air from the park that we create travel into the urban environment? And how much of that cooling would we generate that benefits people, for example, during the day or during the night? We were not able to answer these questions. Ecological footprint, also the carbon footprint would be very interesting, because once we run 70% less irrigation, that of course means you also run much less of the pumps that you need to irrigate or to push the water into the irrigation system. Your control systems are switched on much less, so all the solenoids that you need, all the fuse boxes and pump systems within the park are used less. Would be very interesting to calculate that too, but we just had no capacity for that.
Okay, and we have another question for you that actually comes from Brian, and it's about materials. You guys talked about digital layers, automation, control, but how about hardware, different types of materials? So Brian is asking about the materials that have been used in construction, right? That may or may not contribute to urban heating. What's coming? What are the shifts that you are seeing, for instance, in roofs or other types of materials that everybody maybe should know about and could think about how to use those new materials?
There's my nemesis, particularly for Western Sydney. Black roofs, dark roofs is something for new built environment. We see a sea of dark roofs in our suburbs, and it's absolutely counterproductive because of its thermal properties and its impact on the thermal environment inside the house and how much cooling you would need in summer, but also because you have a mass of dark roofs, you are warming the air for your whole suburb. So everyone cops it. So that's the first thing that I personally fight for. I wouldn't say fight, but I advocate with data against the dark roofs for at least 5 years now. There is a very slow shift, but the industry is just pushing a certain format of housing forward. There's also a shift that we now see in prefabricated housing, which is very interesting. Just to mention another way of how we build homes, which makes absolute sense. We've done it that way for about 30 years in Europe very effectively. So this technology is finally arriving in Australia, hopefully at scale. The other one that we're experimenting at, even at Brian's school, we're experimenting with green and other types of concrete, so greencrete or glasscrete, where we try to take carbon out of concrete because we are so reliant on concrete, reinforced concrete, and so on for our various infrastructures. How do we get the carbon footprint lowered for those kind of materials? Lots of research going into that, and we've got very interesting results that are promising that we can reduce the carbon footprint of our construction industry.
Ben Paul, I think that you have already answered this. So we got a question from a colleague called Kao Young, and he's asking about emerging nations and poor countries. How could they do the type of thing that you guys are mentioning? I think if you guys have any thoughts or reflections on that, you Paul mentioned about, hey, give me $1, I'll give you 3.3 back, right? That economics should work everywhere. But any reactions on this perceived trade-off, I would say?
It's a lot of times it's difficult to sell control systems, automation systems, but they do pay back if they are implemented properly and continued with and actually utilized. A lot of times you have to sell it not only to your management or to your government, but also to your maintenance department, because they may not understand or like it. They may feel their jobs being replaced. But if you can get any system and you can make huge accomplishments by sticking with it and expanding it and integrating it into every aspect of your buildings or whatever it is you're controlling. One of the things I didn't even mention, but what we do out here is I actually control production processes for manufacturing aircraft. And that I don't know of anybody that does that, but I was able to gain such a good reputation over time of being able to control things that production and maintenance actually comes to me and asks me to take get rid of their local Allen Bradley controllers or whatever they're working with, and say, look, can you take control of this and put it on your system, so that we're not continually having to upgrade and replace, and so you can start small, but you just have to be consistent and grow with it.
Perfect. We are approaching the end of our session. Before we turn to some final words from Sebastian and Paul, Deborah, any final reactions or comments or maybe questions that our colleagues could address in our final round?
No, I just wanted to add to the discussion about building materials. I was intrigued by that because if you look at traditional materials and traditional building construction, Sebastian, you're looking at a nature-inspired irrigation smart system for cities, but you think of the American Southwest, adobe, and how that building material was used for both heat and cooling in the Southwest, where you had very hot days and cold nights. Similarly, in traditional architecture, in the Middle East, the flat roof type of mud brick that goes back to 4,000, 5,000 years BC was also designed for those cooling systems without modern technology. So that's something to think about as well, when we look at how building materials can be both a environmentally benign, but also achieve some of the things without digital technology. I'm saying this as an archaeologist, but I was intrigued by your comment on that. But I want to thank you both, Ben Paul and Sebastian, for really outstanding case studies and examples of what we need to do to build resilient infrastructures and how you respond in real time to these serious climate really volatility that I think is only going to continue. It's not going to be abated in the future.
Ben Paul, final comments, maybe a final recommendation that he would give to everybody listening to this.
I guess final comment, just reiterate some of the things I said. You do need to install automated controls, and you do need to stick with a common system and continually integrate it and use it. And you will see nothing but positive results going forward.
Sebastian.
Just picking up on Deborah again, you mentioned Athens, where you work, Deborah. All the homes there are white. That's just what you do. You build in thermal capacity in your environment. We forgot about lots of these principles. In Australia, the settlers' homes 200 years ago had wraparound verandas.
Yes.
We keep forgetting. In Europe, triple glazing is standard. In Australia, we still build with single glazing our new homes. So there's lots of things that we can do. The one thing that I would like to provide as a takeaway is that we need to stop doing pilots and think about working at scale. This is just something that we can't dibble-dabble around anymore. We need to think about working at scale. When we think of cities, the populations, and the impacts that they will be exposed to. So we need to come up with solutions that are financially viable, but effective in terms of their mitigation at scale.
Thank you.
Ben Paul and Sebastian, it was a pleasure to have you here today. There's one thing that I got in my mind listening to both of you. For sure, a lot about technology, how to use digital technologies. But the thing that stuck in my mind is economics. And it's really is about showing that those things are viable and that they will pay back. So that's something that I am taking home. It was an honor and a pleasure to have you here. And we have a final tradition in the GFCC. We always take a picture. So please look at the camera, and we're taking a picture of the session. And this session will be available on the GFCC community. If you are a member or a fellow of the GFCC, you can use our private social network to access this content. If you're not, please get in contact. We would love you to be part of the GFCC community. Thank you, Deborah, for being here with us again, and your leadership in this conversation and the journey.
Martin as well for hosting these webinars, and colleague Christopher Geiger. Thank you.
Thank you so much. Bye-bye.
Thank you.
Bye.
Thank you for having us.
Thank you.